Just because we can't see something doesn't mean we stop asking about it. The questions are still valid. The answers, if we have them, must rest on foundations. Sometimes on assumptions, but more often on well-supported models, constructions of logic, math, and experiment that align with what we can observe. It's humbling to admit that even the sharpest human mind is bound by constraints that aren't intellectual, but physical. It's not ignorance that limits us, it's physics. Information can't travel faster than light. And space, in some directions, is expanding faster than that. These two facts together define a hard edge around our understanding. Not because we're not clever enough to cross it, but because reality won't let us. And yet, we've crossed so much already. We've looked into galaxies billions of light years away. We've captured light that left stars before the Earth had formed. We've seen the afterglow of the Big Bang, faint microwaves that whisper across the universe. We've measured the shape of space, the age of the cosmos, the birth and death of stars. We've even inferred the presence of invisible matter and mysterious energy, things we've never seen but can describe with astonishing precision. That's the real miracle. Not that we can't see everything, but that we can see so much. We live in a sliver of space-time, on a pale blue dot, orbiting an ordinary star. And yet from here, with nothing but photons and equations, we've mapped a universe 93 billion light-years wide. Let that sink in. Our tools are humble. Telescopes, detectors, satellites. Our math is centuries old. Our knowledge is evolving, imperfect, incomplete. And still, we've built models that can predict supernovae, black hole mergers, and even the early conditions of the universe with stunning accuracy. Even if the unobservable remains beyond reach, that doesn't make our effort meaningless. It makes it more precious, because we're not just compiling data. We're telling a story written in starlight, in background radiation, in the subtle bending of light as it crosses curved space-time. We're decoding a vast cosmic library, one photon at a time. And yes, there are pages we'll never read, chapters sealed by distance or redshift or expansion. But we still glimpse the arc of the plot. We still see where the story has been, and where it may go. We know that time, like space, has a curvature, that gravity can warp it, that velocity can stretch it, that there are regions of the universe where time flows differently, where clocks tick at unfamiliar speeds. And now, as we turn back to a time, we ask new questions. How old is the universe? How long will it last? Is time eternal, or did it begin, and might it one day end? Is time a straight line, or something more complex? And can we trust our senses, built for seconds and minutes, to understand billions of years? The answers lie ahead. They require not just data, but imagination. Not just models, but perspective. Because to understand time is to understand change. And to understand change is to understand ourselves. So, as we leave the edge of space behind, we now begin the next journey, a journey into the nature of time, its origins, its shape, its limits, and what it truly means to live in a universe that ages, evolves, and remembers.